Hey everybody, we are going to discuss vertical shift today. I hope to make this short and sweet, but hopefully you will be able to pick up on this very easily. The vertical shift is just like every other function. It's going to be hanging out down here on the end. Obviously, if you add a d, the entire graph is going to go up, and if you subtract a number, the entire function is going to go down. So if we start, and I've got pi going over 3 units, I'm going to use the same scale that we have used the entire time. 1, 2, 3, 1, 2, 3. So this is negative 2 pi, negative pi. We're going to go up 1, 2, 3, 4, and down negative 1, negative 2, negative 3, and negative 4. We know that our regular y equals sine of x is going to start at 0, 1, 0, negative 1, 0. We're going to dot that in. Negative 1, 0, 1, 0. If we want to graph y equals the sine of x plus 3, that means we are going to take our x-axis, which is at 0, we are going to move the entire graph up 3 units. Every single point is going to go up 3 units. Now, just like I had you draw a new y-axis when we did a horizontal shift, when I do a vertical shift with our trig functions, I am going to draw a new x-axis. And so my 0, 0 now becomes 0, 3. And then I'm going to go over 3 units and go up to 4. I'm going to go over 1, 2, 3 units and I'm going to be back down at 0. I'm going to go over 1, 2, 3 units and be down to negative 1. And over 1, 2, 3 units and be back up to 0. So we are looking like this. Go over 1, 2, 3, and where we normally are down here at negative 1, negative 1 plus 3 is going to take me up there to 2. Then if I go to my 0, 0 plus 3 is going to take me to 3. If I go to my 1, we are going to be up there at 4. And if I go to back down to my 0, I'm going to be back down to 3. Now I would like to take a second to discuss our domain and range. The domain of our sine is all real numbers, and the range of our sine is from negative 1 to 1. Y is going to be greater than negative 1 but less than 1. Pardon me, greater than or equal to, and less than equal to 1, because we do actually have a point at 1. If we have y equals the sine of x plus 3, then my domain does not change. My domain is still going to be all real numbers, but my range is actually going to be from 2 to 4. We're going to add 3 to both of those. So negative 1 plus 3 is going to take me to 2, and my range is going to go all the way up to 4 because 1 plus 3 is 4. If I paste one more, let's look at a cosine. If I have y equals the cosine of x, I'm at 1, 0, negative 1, 0, 1. And like I said, in a couple of my classes where people thought it was not necessary to write this down, it is impossible for me to know whether you watch the video if you don't write anything down. So if you want credit, you need to make sure that you have these graphs on graph paper in your notes. If we want to have y equals the cosine of x and we subtract 3, that means my x-axis, which is at y equals 0, is now going to go down 1, 2, 3 units. Every single one of my coordinates is now, we're going to subtract 3 from. So we're going down 1, 2, 3. Sorry, DJ and Jeffrey are interrupting my video for today. Let me pause to see what... All right, so we were at -2, pardon the interruption, -3. We go down to -4. We come back up to -3. And then we're back up to -2. So if you subtract 3, you're subtracting 3 up here in your equation, you're subtracting 3 from all of your outputs. We have 0, 1. 1 minus 3 takes me to -2. 0 minus 3 takes me to -3. -1 minus 3 actually takes me down to -4. And then I'm back up to 0 and back up to -2. We want to talk about domain and range. Domain is all reals. Range is going to be from -1 to 1. For number 3, domain is all reals. My range is going to be from, start at -4, go to -2. So y has to be greater than or equal to -4, but less than or equal to -2. You are subtracting 2 from your domain if you have a vertical shift. Oh, let me paste one more. Go back to sine just because I like it better. Our sine makes our regular up and then down. I should do a survey on Edmodo as to whether you like sine or cosine better. That would be fabulous. Now, let's try something that's a little more interesting. If I give you y equals 2 sine of x plus 1. Here we have a 2 in the front, which is an amplitude change, and then we have a vertical shift of up 1. So I'm going to draw in my new x-axis for my vertical shift, knowing that sine starts at 0, 0. Even if I multiply 0 by 2, that's still going to be 0. And then I am going to, instead of going up to 1 with my vertical shift, I am going to have to multiply that by 2 because I have an amplitude change. So we're going to go up to 3. At pi, we'll be back down to 0. We are then going to go down to -1, and we will be back up to 0 at 2 pi. So we have had a vertical stretch with an amplitude of 2 and a vertical shift, which is our d, which is added at the end. You will have on your quiz some questions that have 1 change, some questions that had 2, some that have 3, some that have 4, and there is a possibility of having 5 different changes to all of your functions, because if you remember, we can have an amplitude change. If there is a negative involved, that is going to be a reflection across the x-axis. We also can have a period change, a horizontal shift, and a vertical shift all at the same time. I'm done. I hope you have a fabulous evening. See you tomorrow.